Today, we're going to learn what a source control is and what role Git plays as a version control system. I'm going to walk you through on installing it and setting up the initial Git configuration. After that, we will learn about the basic Git commands that we use as a developer on a daily basis. Version control, also known as source control, is the practice of tracking and managing changes to software code. Version control systems are software tools that help software teams manage changes to source code over time. Before we define what Git is, let's have a quick look at version control. Versioning is everywhere. Imagine a writer drafting the first chapter of her book. After submitting it to her editor suggested a couple of changes. She then applied those changes, went back to her editor, and repeated the same steps until the last version becomes the final one. Git is a mature, open-source, distributed version control system. It was designed and developed by Linus Torvalds in 2005 to help with Linux kernel development and contributions. Git, like all other version control solutions, was created to address a single issue: change. This has been a frequent problem, particularly when coordinating work on teams, both locally and remotely. However, it doesn't mean that Git is limited to coding. Any product or project that requires or shows characteristics such as numerous contributors, release management, or versioning will benefit from Git's improved workflow. Onto installing Git, go to URL git-sem.com and you'll see links on its documentation, downloads, and even the list of companies and projects that use Git. Let's click Downloads. Git supports the following operating system: MacOS, Windows, Linux, and Unix. If you're on Windows, you can download the installer from their site. Or if you're using a Windows package manager like Chocolatey, you can install it by running this command from the command line or from PowerShell. If you're on Mac, Apple ships a binary package of Git with Xcode. If you type in git -- version on your terminal, if it's installed, you'll get a version of Git. Otherwise, go ahead and install it through Homebrew by typing the command brew install git. It will update it to the latest version if it's already installed. Otherwise, it will go ahead and install it anyway. My Git version was updated to the latest version as of this recording. You can also install it through the binary installer. Go to the site and download the .dmg installer. Follow through the instructions once you double-click it. Here's the rundown of basic Git commands, and I have categorized them into setting up a repo, saving changes, inspecting the repo, and configuring Git projects. If you haven't heard the word repository, in software development, a repository, or repo for short, is a central file storage location. It is used by version control systems such as Git to store multiple versions of files. While a repo can be configured on a local machine for a single user, it is often stored on a server, which can be accessed by multiple users. Later on, once we initialize a Git repo, I'll show you where it tracks all the changes to the project. Let's create our first Git project and let's pretend that we're writing our first epic book. Jump into your favorite terminal and create a directory. Get into that directory. Of course, it will be empty at first. The git init command creates a new Git repo. It can be used to convert an existing unversioned project to a Git repo or initialize a new empty repo. Most other Git commands are not available outside of uninitialized repo, so this is usually the first command you'll run in a new project. This command creates a .git subdirectory in the current working directory, as you can see here, which contains all of the necessary Git metadata for the new repo. Moving on to clone command, I've created a simple project in GitHub to demonstrate how to clone an existing Git repo. Git clone is mainly used to point to an existing repo and make a clone or copy of that repo in a new directory at another location. Here we've successfully cloned the awesome project I've created earlier. Let's look at the .git subdirectory, which contains all of the necessary Git metadata for this repo. If we view the config file, you'll see the configuration of this Git repo, like the branch name and the remote origin URL, which we used earlier along with the clone command. Previously, I've showed the config file of the awesome project. We can add or change configuration values by using the git config command. The git config command is a convenience function that is used to set git configuration values on a global or local project level. We'll be covering common configuration settings like email, username, and editor. The most basic use case for git config is to invoke it with a configuration name, which will display the set value at that name. Configuration names are delimited strings composed of a section and a key based on their hierarchy. For example, user.email. Before we further discuss git config usage, let's take a moment to cover configuration levels. The git config command can accept arguments to specify which configuration level to operate on. The following configuration levels are available: local, global, and system. By default, git config will write to a local level if no configuration option is passed. Local level configuration is applied to the context repository git config gets invoked in. Local configuration values are stored in a file that can be found in repos.git directory. Global level configuration is user specific, meaning it is applied to an operating system user. Global configuration values are stored in a file that is located in a user's home directory, while system-level configuration is applied across an entire machine. This covers all users on an operating system and all repos. The system-level configuration file lives in a git config file off the system root path. Thus, the order of priority for configuration levels is local, global, then system. This means when looking for a configuration value, Git will start at the local level and bubble up to the system level. Let's demonstrate the local config level by adding our username and user email address on our awesome project. You don't need to add the -- local flag, as that's already the default for git config command. Looking at the project's config, it now has the name and email address. Let's add some global configuration. Global configurations are good to set up so that you don't need to do it per project level, particularly the username, email address, and default editor of your choice. As I mentioned earlier, global configuration values are stored in a file that is located in a user's home directory. So if we inspect the file .gitconfig, you'll be able to see all those configs we've added earlier. I've configured VS Code as my editor, so I can just type code and the file name of the file that I want to view, and it will open it from VS Code. Git has internal state management system, or also known as trees. In work tree, you have all the untracked changes, and Git is aware of those. Once you execute git add, untracked files will be added in staging tree. And once you're happy with the changes, you can commit those to the repository tree or onto the commit history. Going back to our epic book project, we're going to add our first chapter. Create chapter1.text. By typing git status, we see that chapter1.text is indeed unstaged. Add it to the staging index, then commit. Type in git log and you will see the commit history. Let's try diff command by updating chapter1.text. Add some text and save it. Type in git status to verify. Now that we have an untracked change, let's compare the change from the initial one by typing in git diff chapter1.text. Okay, looks like it didn't persist the line that we added initially when we created chapter1.text. Thus, the only difference is this one. If, say, we change our mind and we don't really want to stage it this time, but maybe use it later, we can stash it. Git stash temporarily shelves changes you've made to your working copy so you can work on something else and then come back and reapply them later on. Stashing is handy if you need to quickly switch context and work on something else, but you're midway through a code change and aren't quite ready to commit. In summary, we now know what source control does and the benefit of version control system. We also learned how awesome Git is and its internal state management. We now know how to install it in Windows and Mac operating system. And most importantly, we can work on some basic Git commands that we can apply starting today. If you've reached the end of this video, you're amazing. I hope you've learned something new today. Thank you and happy coding!